Hola clase. In our previous video, we were learning to graph linear inequations, and we did the whole process and realized we had a problem. When we are shading in, we realized that the feasible region is quite hard to see because I'm overlapping layer over layer over layer of colors, each one representing one inequation. And we were thinking of what could be the solution to that problem. Now, the solution to this problem is to actually shade out. So if I were doing this process, when I get to shade in the complying area, what I do is that I shade out the non-complying area. That means that the feasible region at the end is going to be what remains unshaded, which means it's going to be much easier to see. So if we do this exact same example, but now we shade out, and if we start and try to use the same colors, everything else remains the same. So I can go and find the first of the boundaries when x equals 3, and now the area that complies, x smaller than 3, remains unshaded. I can repeat the process over and over, so if we use the same color than before, we find the boundary for y smaller or equal than 2, and now the area that is smaller or equal than 2 remains unshaded, and I shade out the area that is bigger than 2. So now you see that the area that is unshaded after 2 rounds, it's getting smaller, but I can see it quite easily, not like before. Same thing for the third of the equations. We already found our y-intercept and second point. This is still a strict equation, so the line is still a dotted line. But now, because the area that complies is above, I shade below the boundary. After I've done that, now the feasible region, this part that in our previous example was covered by many layers of color, now it's whatever remains unshaded at all, and now it's much easier to see. Now, if we're doing this in some kind of context, we are going to want to use the time we've got to actually make sense of the numbers rather than on drawing and coloring. So we will do this on a computer. In our case, we are going to use GeoGebra because it's free and it's quite self-explanatory. If you're going to do that, you go to geogebra.org in the browser that you choose, and then you go to Graphing Calculator. That opens a new screen that looks like this, in which I've got the graphing area, I've got the keyboard that I can collapse and expand again if I need special characters, and then I will see the equations that I'm using in this bar in my left side of the screen. So now I simply need to type each one of the inequations instead of drawing them by hand. If we do the first one, x smaller than 3, you see that it immediately graphs it there using the conventions that we know. That line is discontinuous. But now I need to use the option to shade out. So I go to these 3 dots, that gives me several options, and I click on settings. There is where you can change everything you want of anything that you do in GeoGebra. I can change the name or the definition of that object, which is that inequation. I can change the color. We're going to leave this one blue for the time being. And the important part for now, in style, I need to click inverse filling. That is how I tell GeoGebra to shade out. And if I see now, it's shading out the part that doesn't comply, the boundary doesn't change, and the convention still hasn't changed. That's still a dotted line. And now I just repeat the process over and over. If I do the second one, now I'm going to use the keyboard because I need y smaller or equal than 2. And you see by default, it gives me the same color. I can change that in the settings, So same deal. Now we will change the color. We left it blue before. Let's go green. And the important part is that in the style, I click inverse filling. And you see that it automatically sees it flipping. The line is still a continuous line, and you see it's called B, and I see it labeled as B in the screen. Let's do the last one. Y smaller than minus 2x plus 4, and you see that it always goes back to blue as default. So we're going to change it, orange. And the important thing, in style, inverse filling. We have to do it for every one of the inequations. The important thing is that now I see that feasible area very clearly, and I can use that for anything else. As you can see, that it's faster than actually doing it by hand, which will free time for actually making sense of the numbers rather than doing the graphing itself. Now it's your time to go and practice. Thanks for watching.